In this video, we're going to focus on solving problem number 1.2.9s in Broverman. Find the 2-month interest rate for two equivalent payment streams. The problem statement goes, a contract calls for payments of $750 every 4 months to be made for 7 years. And then it's going to be replaced by something new. Each payment is to be replaced by two payments of $367.85 each, one to be made 2 months before and one to be made at the time of the original payment. Find the 2-month rate of interest. That's what we're going to find here, implied by this proposal if the new payment scheme is financially equivalent to the old. All right, as always, so far at least, we start by drawing a number line. And seemingly, if you start thinking about it here, you want to label these tick marks to be, say, 2 months apart. But I think this problem, if you start to think about it, is a little trickier than the ones we've had so far. It's not clear, for example, whether the 750 should be made at time 0 or at time 4 months to start with. If it were time 0, the 367.85, evidently by this fact that it's going to be made 2 months before, would have to occur in the past, so perhaps you prefer the 750 to start at time 4 because of that. It's really not clear, and because of that it's confusing. And even if you do go ahead and decide, okay, I want my 750 to start at 4 months, and then the next payment would be at 8 months and 12 months, and then based on how this 367.85 is described, have my first payment of 367.85 be at time 2 months and at time 4 months, because the first one is 2 months before and the second one is made at the time of this 750. If I go ahead and decide to do that, it still looks like it might be kind of difficult because, well, there are a lot of payments here. You're out of room on the diagram, which does sometimes happen. You have to sometimes figure out how far you need to go out without actually drawing it. But that looks like a pain. And in reality, when I first was thinking about this, I'm thinking, okay, I need to set the present values of these things equal to each other, say at time 0. I guess I'm going to have to use some sort of finite series, a geometric series, in fact, if you know a little bit about geometric series, which in Chapter 1 problems, we're not really assuming you know about those yet. And this is a Chapter 1 problem, though on a exam 2, you wouldn't necessarily know it's just a Chapter 1 problem. I ended up solving it that way, but it was kind of a pain. But when you encounter something like this, that's, I think, intentionally a little confusing, take a step back and say, you know, maybe there's a simpler way to solve this. And the simpler way to solve this is to just focus on the first groups of payments in the first 4 months. Because if you can find an equivalent interest rate, equivalent 2-month interest rate for these first 4 months, two groups of 2 months, based on a present value of time 0, that same interest rate will work for all of it. Because, for example, if you found that you used that same interest rate for this group and discounted back to time 4, the answer you get for the first group would be the same as the answer you get for the second group, because then if you discounted to time 0 again, you still need them to be equivalent. Maybe that was confusing, but that is the idea, that you can just focus on this first group. So all we need to do now, if V is the 2-month present value discount factor, what we need to do is we need to set the present values of these two things, this stream and this one payment, equal to each other at time 0. So 750 times V squared would equal 367.85 times V plus 367.85 times V squared. I'm doing it at time 0. Actually, I could find equivalent values at time 2 or time 4, and in fact doing it at time 4 might be a little simpler because I'll get to my interest rate more directly, but let's go ahead and finish it this way. So actually V can't be 0, so you can cancel one of the V's in all these, and that's true because V can't be 0. And then you could isolate V on one side by taking 750 minus 367.85. On the left side, we'll get 382.15V coming from taking 750V minus 367.85V after canceling one of the powers of V equals this number. I already canceled that V, equals 367.85. So V is going to be the fraction 367.85 divided by 382.15. 367.85. Well, let's take the reciprocal of the 382.15 and multiply by 367.85. Looks like V is 0.96258. I'll go ahead and round it to that. And then, as usual, I can be found now by doing the reciprocal of V and subtracting 1. Take the reciprocal of that. Again, this is a 2-month rate. Subtract 1. Our answer is 0.03887, or 3.887% if you were asked to convert it to a percent for some reason. Okay, let's see how we do in time. Maybe we should go ahead and solve this a second way. Let's also demonstrate that we could have solved it by finding the equivalent value at time 4 by thinking about pushing amounts into the future. The 750 and this 367.85 are already at time 4. So I could say 750 equals 367.85. And then with this one, I need to put that 2 months into the future. Again, I will be a 2-month rate, so I can just take that 367.85 and multiply it times 1 plus I, where I again is a 2-month interest rate. Once again, subtract 367.85 from both sides. You'll get 382.15 equals 367.85 times 1 plus I. 1 plus I will be the ratio. 382.15 divided by 367.85. You'll find that ratio, then subtract 1, and you'll get the same answer. Let's just confirm that quick. That should make sense algebraically if you look at these equations. 382.15 divided by 367.85. Subtract 1 from that. We get the same answer, about 3.887%. Let me go ahead and do it so you can see it again here. 382.15 divided by 367.85, subtract 1. There we go. So you do get the same thing, and that is the 2-month rate. And again, this problem is, I think, definitely trickier because it's like they're purposely confusing you by putting extra information in that you don't really need to think about. So you should watch for that as you solve problems.